Hi guys, this is Miss Best. This video is going to be on completing the square. Completing the square is just another method that we use to solve quadratic equations. So far you guys have learned how to solve quadratics by factoring and by square roots, and you've even solved quadratics that have complex square roots. And now we're just moving on to completing the square. The first thing I want to talk about is that completing the square can change standard form quadratic equations to vertex form quadratic equations. There are some benefits of using completing the square. The first benefit is that it highlights the vertex of the quadratic, and it also finds solutions to unfactorable quadratics. So if you're wondering why can't I just factor, or why can't I just solve by using square roots, it's because some quadratic equations don't allow you to. Not all quadratics are factorable. Alright, so that leads me to my next point, when to use completing the square. So you use completing the square when you can't factor. You also use completing the square when you need to know some info about the vertex, because like I said earlier, that you can change a standard form equation to a vertex form equation. What do you need to know in order to complete the square? You need to know what completes the square, what value can you plug into the equation to complete the square. You need to know how to factor a perfect square trinomial. And you also need to know how to solve by square roots. Okay, so as you can see, we're taking steps and skills from over the past 2 weeks and putting them into this skill. Okay, all right, so our first example, we're going to solve by completing the square. Our first example is x squared plus 6x plus 3 equals 0. So first let's look at the equation and see if we can factor it. Do we know any factors of 3 that will combine to be 6? No, the only factors of 3 are 1 and 3, and 1 plus 3 makes 4, so this is not factorable. So we're going to complete the square. So the first step in completing the square, I'm going to do my work over here. Okay, is to move C. All right, so if you don't know what C is, we need to go back and label our quadratic equation. Remember that A, B, and C are the coefficients in the quadratic equation. So our A is 1, our B is 6, and our C is 3. Okay. So let's make that our first step. Step 1, label. Okay. All right, so the first step is to move C. So I'm going to subtract 3 from both sides. These 3's will cancel out, and now I have x squared plus 6x equals negative 3. All right, my next step is to complete the square. Complete the square. All right, so how do you complete the square? You can use a formula, which is b over 2 squared. Okay, our b is 6, so it will become 6 over 2 squared. 6 over 2 is 3, so now I have 3 squared, and 3 squared is 9. Okay, so 9 will complete the square. So I'm going to plug 9 into my equation. So now I have x squared plus 6x plus 9 equals negative 3 plus 9. Remember, whenever you're solving an equation, you have to keep it balanced. You have to be equal on both sides. So if I added 9 to the x squared plus 6x, I have to add 9 to the negative 3 as well. All right, so now I'm going to simplify. X squared plus 6x plus 9 equals 6. All right, so now that complete the square part was a little too fast for you, or maybe you don't get why that completes the square. Let's go over here to the left hand side, and I'm going to show you guys a little drawing to show you why it's called completing the square, or just to give you like a visual reference as to why it's called completing the square. So let's take this square here. All right, let's say that this is x squared. All right, and so now I'm going to take 6 little line segments, 3 up top and 3 on the side, and that will represent our 6x. So now we have this kind of L-shaped figure, okay, and we need to make it a square. So what can I do to complete the square? Well, if I can only fill in the space here, okay, with dots, this is how it would look. I would have 1, 2, 3, 4, 5, 6, 7, 8, 9. So now I have a completed square. I no longer have an L, I have a square. Okay, so that's why it's called completing the square, and that's why 9 completes the square. All right, so now here comes the part where you need to factor. Okay, and you guys should recognize this type of quadratic already. It's a perfect square trinomial. So remember, perfect square trinomials have a is squared and c is squared, and then the middle is a combination of the two. All right, so factors of 9 that will add to be 6, that's 3, okay? Or just think of it as you're taking the square root of 9. Square root of 9 is 3. So that makes this x plus 3 times x plus 3 equals 6. Now, when we're doing completing the square, we don't write it this way. Okay, we want to go ahead and write it in its simplest form, which is just x plus 3 squared. So I'm going to erase this and write x plus 3 squared. All right, so now we're almost done. We have to solve by taking the square root. So we're going to square root it. Okay. Take the square root of both sides. Okay. And so anytime I take the square root of a square, I'll just be left with what's underneath. So this becomes just x plus 3. And then because I solved by using the square root, I had to put my plus or minus the square root of 6. Now 6 doesn't have any perfect squares that are factors of it, so we're just going to leave it the square root of 6. One more step, I'm going to subtract 3 from both sides. And now I have x equals negative 3 plus or minus the square root of 6. And remember that this means negative 3 plus the square root of 6 or negative 3 minus the square root of 6. And you'd be done here. These would be your solutions. Okay. All right, so now we solved by completing the square. So let's take this example and show how you can use it for the vertex of the quadratic. All right, so if you're doing completing the square, or if you have a standard form quadratic equation and your question asks you about the vertex, you're going to complete the square up until this step right here. Okay, this is where you're going to get your vertex form. So you don't have to take the square root and do the plus and minus and all that stuff. You can stop right here at x plus 3 squared equals 6. Okay. All right, this is how you get your vertex form. So if you look back up at the top of your paper, I'm going to scroll up really quickly. Vertex form is a times x minus h squared plus k. All right, and then go back down. We are very close to that. The only thing we need to do is subtract 6 from both sides so we can get everything over to the left-hand side. So I'm going to subtract 6 from both sides. These cancel out, and I'll be left with x plus 3 squared minus 6 equals 0. And now I have vertex form. So the vertex of this is going to be opposite HK, okay? And for this particular quadratic, it will be negative 3, negative 6. All right, so I'm going to stop this video right here, and if you need to pause or rewind it, please do so, and then just stay tuned for the next 2 examples.